Okay, we are now continuing with section 4.2, an area. So what we're trying to work on right now is finding the upper and lower sums of the region bounded by the graph x squared between the x-axis and x equals 0 and x equals 2. So from the last page, we are trying to look at, we need to find delta x, which is b minus a over n, or 2 minus 0 over n, which is 2 over n. And then we have two different endpoints. We have the left endpoint and the right endpoint. So left endpoint is little mi. We do a plus I minus 1, because we're trying to get to the left, times delta x, which is 2 over n. So our left endpoint is 2 times I minus 1 over n. And our right endpoint is capital Mi, a plus I times 2 over n, which is 2i over n. So we're going to use both of those to make our approximations for the sum. So let's start with the left. So our sum is equal to summation of 1 to n of f of little mi times delta x, which is f of, and we figured out what our little mi was, 2 times I minus 1 over n times delta x, which is 2 over n. Okay, we need to plug that into the function. I equals 1 to n of 2 times I minus 1 over n, that whole thing needs to be squared, times 2 over n. Simplifying that, we square the top, so we're going to have 4 times I minus 1 squared over n squared. We're going to pull out our n terms. We're going to have 8 over n cubed on the outside that we can pull out. And then the inside, we have the summation of I equals 1 to n of I squared minus 2i plus 1. So we can now break that up into 3 different summations and use our summation from the first page to simplify them. So 8 over n third, I equals 1 to n of I squared, minus 2 times the summation of I equals 1 to n of I, plus summation of I equals 1 to n of 1. 8 over n to the third stays out front. And evaluating the whole thing, let's get back to that first page to figure out what those summations are. The summation of I squared is 2n cubed plus 3n squared plus n over 6. Second one, summation of I, is n squared plus n over 2. And the third one is just n. Okay, so now if we are going to simplify this, I'm not sure what the easiest way to do this is. We could distribute the n cubed into every term and the 8 into every term. 16n cubed plus 24n squared plus 8n over 6n cubed plus 8n squared plus 8n over 2n cubed plus 8n over n cubed. And then we can simplify. Everything's going to simplify to 8 thirds minus 4 over n plus 4 over n cubed. 4 over 3n squared. This is our lower sum. Okay, we have to do the upper sum. I think the upper sum is a little bit easier. Our sum is summation of I I equals 1 to n of f of capital Mi times delta x. Our capital Mi was 2i over n, and delta x was 2 over n. Put that into the functions. We have the sum of I equals 1 to n of 2i over n's quantity squared times 2 over n, which is delta x. And then pull out our n terms. So we would distribute this. We'd have 8 over n cubed times the summation of I equals 1 to n of I squared. And then we would put in the value for I squared, which if we want to just look right up above, we can find out what that is. 2n cubed plus 3n squared plus n over 6. We would distribute that 8 into our, there we are, 16n cubed plus 24n squared plus 8n over 6n cubed. This would simplify to 8 thirds plus 4 over n plus 4 over 3n squared. This is our upper sum. Obviously that one was a lot faster. I want to compare the upper between the lower. The only difference is a subtraction sign versus a plus sign for that 4 over n. Okay, so now we're talking about the limits of our upper and lower sum. Notice how similar our two sums were. Well, we know that if we find the limit of our sum as x approaches infinity, it's the same thing as taking the limit of our lower sum, which is equal to the limit of our upper sum, which is equal to the limit of our sum in general. So if we go back and look at our two sums, we have the upper and lower. If we took the limit of each one of those, limit of the upper as x approaches infinity, or n approaches infinity in this case, would be 8 thirds. And the limit as x approaches infinity of our lower, it would also be 8 thirds. So that holds true that if we take the limit of our upper and lower sums, we would get the same answer, which is the approximation of our sum. So delta x is b minus a over n. Fmi and Fmi are the min and max. So this is what we're going to do. The definition of area is the limit as n approaches infinity of pretty much what we've been dealing with. The only thing we need to mention is that our CI is a plus I delta x. And I think we were actually using that for our MI and capital MI. Okay, so now we are going to find the area of the region bounded by x cubed, the x-axis, and the vertical lines 0 and 1. So our interval is from 0 to 1. Delta x is b minus a over n, which is 1 over n. Our CI is a plus I delta x, which in this case is 0 plus I delta x, so I over n. Our area is the limit as n approaches infinity of I equals 1 to n FCI delta x, that was our definition from the last page. So now we're going to plug everything in where it belongs. F of CI is going to be I over n quantity cubed times 1 over n. I'm going to save writing the limit over and over and over. We're going to keep that until the last step. We can pull out a 1 over n to the 4th, and now we are just taking the sum of I cubed. And the sum of I cubed is also on that first page. It's n to the 4th plus 2n to the 3rd plus n squared over 4. And now we can distribute that in. So pretty much the only thing that we're doing now is putting the n to the 4th on the bottom. That's a 2 over 4n to the 4th. If we were to take the limit of this as n approaches infinity, it's going to be the only looking at the greatest exponent. The greatest exponent is 4 on the top and the bottom, so our limit is 1/4. That's the approximation of our area. Save us a little bit of time. We're just going to do this example and skip the next one, although the next one we would do the exact same way, only with y's instead of x's. So let's just do this next example. We're dealing with 4 minus x squared when our vertical lines are 1 and 2. So our interval is 1 to 2. And our delta x is b minus a over n, which is 2 minus 1 over n, or 1 over n. And our ci is a plus 1 times delta x, 1 plus I times delta x, which should be I over n. And now we're going to put everything in there where it belongs. Limit as n approaches infinity, which I'm just going to write this first time. I equals 1 to n of fci. So we're going to put ci into our function f, which would be 4 minus 1 plus I over n quantity squared, whole thing times I over n. So distributing all that, we get 3 minus 2I over n minus I squared over n squared, all times 1 over n. So we actually have to pull this into 3 different summations because it's not the same value of n that we can pull out. First one, we just have a 1 over n and 3. Second one, we have 2 over n squared and I. Third one, we have 1 over n cubed, and our summation is I squared. Then we can take the summation of each one of those and do the limit. And our limit is 3 minus 1 minus 1/3, which is 5/3. Okay, and like I mentioned before, we're going to skip the last one for sake of time on the video. But just one quick change to your homework. You're going to skip number 28. Otherwise, you should be good to go on section 4.2 on area.